In the last lesson, as we looked at some of the graphs of some of these standard important elementary functions, we noticed that some of them had certain symmetries. In particular, f of x is equal to x squared look like that very roughly, parabola. And the important thing that I'm pointing out to you at this point is that you could fold this graph right over the y-axis and it would fold right on top of itself. So this part here would lie right on top of that part here. A function that has that property is called an even function. An even function is one that has this property. If you were to take a value x and then take negative x, the exact opposite of x, the value of the function at those 2 points would be exactly the same. So written out in symbols, f of negative x is exactly the same value as f of x. So any function that has that property is going to be symmetric with respect to the y-axis. As I say, you could basically fold it right over the axis on top of itself. And we had quite a few even functions. X squared was one of them. Other ones that were on that list that we just did was 1 over x squared. Remember, that one looked like this. That was an even one. Another even one, I'll call it k of x, is absolute value of x. Those three all come to mind. Looks like that. So those are all examples of even functions, and they, as I say, they have this property right there. On the other hand, you also have functions that we say are symmetric, not with respect to the y-axis, but are symmetric with respect to the origin. So for example, g of x equal, let's say 1 over x as an example. Looks like that. What this is called an odd function. An odd function is one that has the property that if I start with an x right there, and I take the exact opposite right there, and look at the values of the function, notice that the values of the function are not the same as they were here, but one is the exact opposite of the other one. So it satisfies this property. F of negative x is the opposite, the negative of f of x. So that's an odd function. And we had several others as well. Here was one. Oh, here's a simple one. Just y equal x is one. Another one is the cube root of x. Look like that. Another one is, I'll just put cube root of x here. Another one is x cubed. Which look like this. So all of those have the property that whatever the value of the function is here, it's the exact negative if you take the opposite of x. It's just the exact opposite. And so those are odd functions. It's a little bit harder to see what they're symmetric to. We say they're symmetric with respect to the origin because you could think of balancing the function right there on the origin. If you were to put a pin, if you were to think of this as being a mobile or something like that, and you were to balance it on a pin, you could balance it right there at the beginning, at the origin. So those are all odd functions. So so let me write down the definitions here right together, and then we'll have the rest of the board available for more examples. So even f of negative x is equal to f of x, and odd f of negative x is the opposite of f of x. So I gave you a bunch of examples, but we could draw other examples that would be similar. So here, just to make an example, see if I can make the, whoops, something like that. There would be an even function, because everything that happens on this side, it just does exactly the same thing on the other side. You could fold it right over the line y equal x. If this were an odd function, then what would this side look like? It might be kind of hard to visualize. I guess it would go down like this. Whoops, not all the way. And go down like this, and back up like that, roughly. Okay, that'll make it an odd function. Okay? So, quite often, if you have an even function or an odd function, it's kind of nice to know. Just as one example, if you happen to know that the function is even, and you want to know what the graph of it looks like, well then you know, if you know that the one side looks like this, then you don't even have to worry about the other side. If you know it's even, then you know it's going to, again, look like that. So it's going to do exactly the same thing. So if you happen to know a function is even or odd, it's kind of nice to know that. It helps you understand what the function is going to do. So let's see once if we can figure out how to determine if functions are even or odd. Let's take an example of f of x is equal to, let's say, x cubed plus x divided by x squared. Let's determine whether that's even or odd. Or it could be neither. Right? Obviously, not functions don't have to be either. If you just draw any old function, there's a function which is neither even nor odd. So most functions, I guess, would be like that. So we're looking at special cases if a function happens to be even or odd. So here's how you do it. If this is the function, what you do is you take f of negative x, and then you see once what f of negative x happens to look like by the time you simplify it all out. So what does this say? This says right here, what does f do to x? It first cubes it, then it adds x, and then it divides that whole thing by the square of x. So whatever you stick in here, you have to do this, and then this, and then this to it. So if I stick this thing into f, what does f say to do? It says to take that thing, and you first cube it. So be very careful. Whatever's in there, you first have to cube it. Then you add that to it. And then you divide it by, in this case, that thing squared. So f of negative x looks like this. Now we can simplify it. Notice that this is the same as all of these. If I wanted to, I could write that as negative 1 times x, negative 1 times x, negative 1 times x. And the properties of exponents, if you have two things that are all taken to the third power, it's going to be this thing cubed times this thing cubed. So negative 1 cubed is going to be negative 1 times negative 1 times negative 1 is still going to be a negative 1. And then x cubed is going to be x cubed, like so. Here you have just negative x, and so I can just write, I'm just going to write that as negative x. I'm going to get rid of that 1 now, just write it like that. And then finally on the bottom, I have negative 1 squared times x squared. So negative 1 squared is just going to be 1. 1 times x squared is x squared. So you get this right there. And now notice that I can factor a negative 1 out of both of these terms up on top, and I'm left with x cubed plus x on top, and on the bottom I've still got my x squared, and I look and I notice, that's exactly what my original function was. So this is negative f of x. This right here is f of x. So what did I conclude? f of negative x is equal to negative of f of x, and that's exactly what an odd function is. So this particular function is odd. We say it again, f of negative x, go through and simplify, it's going to be equal to negative f of x, so that kind of function is odd. Let's change it just slightly and see what we get. Change this to a 5. So now this becomes a 5 right there. And let's see what happens. You put in a negative x for x, and this will become negative x cubed, quantity cubed. This times this, each one of these cubed as before. And this will stay the same as before, but now this will be a 5 right here. So what changes? This is all the same. Here we have negative 1 to the 5th power, which is going to be a negative. And this will be x to the 5th power, will be x to the 5th. So it'll look like that. Now we can still have the negative taken out of both of these, but now we also have a negative down here. And so those two negatives cancel, and we notice that we end up with exactly the same function. Whoops, here 5. This is also a 5. So we end up with exactly the same function that we started with. So this function here is no longer odd. This one is even. That one is even. So there's that one. And finally, what happens if we change this, say, to an x squared? How does that change things? Let's get rid of the even here. And if we have an x squared there, this becomes a squared. And now we have negative x cubed. Here we have a negative 1 times negative 1 is going to be a positive x squared. And this stays the same. And now, notice that this thing right here is neither the same as this or the opposite of this. It's not identical, nor is it the negative. If I wanted to factor a negative out of the top, I still could do that. I could write this as x cubed minus x squared. And on the bottom, I'm going to have a negative x to the 5th. That's all fine. Now I can cancel this negative with this negative. But notice I don't end up with what we started with. It's x cubed minus x squared over x to the 5th. So this would be an example of a function which is neither even nor odd. So there's a quick introduction, or not even a quick, there's a pretty good introduction to even and odd functions.